let's consider an example where an object acts under the influence of gravity, where it is moving in one dimension and it's given some initial velocity. So here our example is that a ball is thrown vertically upward with some initial speed of 24 meters per second, and we want to determine how long it takes the ball to reach its maximum position, how high does the ball actually rise, and how long is the ball in the air before it returns back to its starting position. So let's try to examine this problem from a conceptual standpoint, and then we'll work through it with using some formulas. So let's try to just do that conceptual analysis first and see if we can understand what's going on. So we have this object and it's given some initial velocity of 24 meters per second at time t equal to 0. It's released, and we know that gravity is acting downward, which means that this object is going to slow down by 10 meters per second every second that goes by. So after 1 second, the object's velocity should have decreased by 10, so it went from 24 to 10 after 1 second. After another second passes, the velocity should decrease by another 10 seconds, so it's decreased down to 4. But here's the problem. The problem is that we can't take away another 10 from this, right, to get to the top. So we want to know how long does it take to get to the top, and in the previous examples we had even numbers, right? We were using values of, we used 40 for the initial velocity. And so that makes solving problems much easier, and that's the whole reason that we use 10 for gravity, because it's easy to look at the differences by factors of 10. So how do we analyze this if we can't take another 10 to get to the top to get to 0? So what we can do is we can say, all right, well, we know that when it reaches the very top, its velocity has to be 0, and we want to know what is this time. Since I can't take away another 10, I know the time is not 3 seconds, because I'd have to be able to take another 10 away to get to 3 seconds. So it has to be something between 3 seconds and 2 seconds, somewhere in between there. So it turns out that the speed, every second that goes by, the speed changes by a factor of 10, but we could also say that the speed decreases on the way up by 1 meter per second every tenth of a second that goes by. In other words, if I break up this 1 second interval here and I divide it by 10, because there's a change in 10 here of the speed, then I would break up this time into tenths. And so I can think about the fact that the speed changes by 1 meters per second every tenth of a second. So let's think about what's going on. So we're looking at a close-up now of this last part of the motion, and it's a blown up picture so that we can see what's going on. So here's our object at 2 seconds, right here, right? Here it is, down here, it's traveling at 4 meters per second. If the object is accelerating under the influence of gravity and it's slowing down under the influence of gravity, every 0.1 seconds it goes by, the speed will change by 1 meter per second. So that means that after a tenth of a second, the speed would be 3. After another tenth of a second, 2.2. So I've taken another tenth, it would be going 2 meters per second. After another tenth of a second, right? I keep adding a tenth on here, it would be going only 1, and then finally it would reach the top and it would have 0 velocity, and the time would be 2.4 seconds. So basically my speed was 4 and I need to get to 0, so that's a difference in 4 seconds, and so I take that 4 seconds and I divide that 4 meters per second, and I divide it by 10 and I get 4/10 of a second. So this is a way you can analyze it if you wanted to. If you don't have an even number here, you can think about how that last small interval can be broken into 1 second intervals, and each one is a tenth of a second. Now what you should realize here is that the time it takes to get to the top is 2.4 seconds. Well, look at our number for our velocity here. It's 24. So if I took 24 and I divided it by 10, I get the time it takes to get to the top. But conceptually, we can also understand what's going on because that acceleration is causing that velocity to decrease by 10 meters per second every second. So time to reach the top, 2.4 seconds. Let's consider the same exact question, but not from a conceptual standpoint, but instead trying to look at the formulas. So we'd like to figure out, we know that it starts off with some initial velocity of 24 meters per second down here at time t equal to 0. We know that we want to figure out the time at the top here. We want to find the time it takes to get to the top. And we know that at the very top, this is our hidden information, that the velocity at the very top is going to be 0. The other information that we know is that gravity is always acting, and so the acceleration due to gravity is always negative 10 meters per second squared. So the information that we have is the initial velocity, the final velocity at the top, the acceleration is negative 10 meters per second squared, and the time is what we're looking for. So we can use the definition of acceleration, which says that the acceleration is the change in velocity, final minus initial, divided by the time. I can multiply both sides of this equation by time, and I can write this expression as acceleration times time is equal to change in velocity. And now I can plug some values in. So I know the acceleration is negative 10 meters per second squared. I'm trying to solve for the time. My velocity at the very top is 0. My initial velocity is 24. And so now I have only one unknown, which is the time. I can get rid of the 0. I have minus 10 times the time is negative 24 meters per second. And if I divide both sides by negative 10, right, to solve for t here, I can divide both sides by negative 10. I get negative 24 over negative 10. The negatives cancel, and I get 2.4. So again, it's sort of what we talked about before. I just have to take what is my initial speed, 24, and divide by the acceleration of 10 meters per second squared, and I get the time that it takes to get to the top. So this is using the formulas rather than using the conceptual basis of looking at how the velocity changes with time. So due to symmetry, we know that it takes the ball 2.4 seconds to fall back down to its position from which it was released at 24 meters per second. So in other words, it takes 2.4 seconds to get to the top. It takes another 2.4 seconds to come back down. So when it falls back down, it just behaves as if it was dropped. So if we want to know how high it rose to get to that point, we can see how far it actually fell from the top point. And so we can use the fact that the distance that the object falls depends on the time that it is in the air. And we know the time it's in the air from the very top until it hits, just before it hits the ground, is 2.4 seconds. So I can take 1/2 g, which is 10 meters per second squared, times the time, 2.4 seconds squared, and I get 28.8 meters. That is the maximum height that the ball reaches. It's also the distance the object falls from the very top until it gets back to where it was thrown from. So we have to make sure we only use the time that it takes to get to the top when we calculate that maximum height. How long is the ball in the air before returning back to its starting position? Well, the time it takes to get to the top is the same time it takes to get back down. So we just double the time it took to get to the top, which was 2.4 seconds. So the total time in the air is 2 times 2.4 seconds, which is 4.8 seconds. So this is just a worked example of an object that's thrown in the air, and you can use this as an example to solve other problems where it has some different initial velocities.